And as you all heard, my name is John Onoja from Lagos, Nigeria, West Africa, and a graduate of chemical engineering in first degree and polymer and chemical engineering second degree. So um, I'll just be carrying you through a little bit of what I have here. I'm trying to see if I have opportunity to share a slide. And if that's possible, I'll do that right away. Can you see this slide?
For now, no. Yep, we can see. We can see,
Oh,
yes.
okay. So basically, I'll just be a bit fast and I'll just go through a bit of my background story so as to usher people into what is I'm going to talk about. So I'm a graduate of chemical engineering with internship in, I did my internship in a water unit or processing plant, after which I did my engineering training in a refinery, the largest single train refinery in the world. If you've heard of the largest single train refinery in the world, that's the Dangote refinery with a capacity of 650 barrels per day. So I had the opportunity to actually go into one of the most intricate part of the plant, which is the motor spirit block. And frankly enough, I was opportune to partake in both the pre-commissioning, the commissioning, and the process phase. And the truth is, a lot of people do not actually know how relevant what you do now is to your prospective future career. What you do now, both at school and the things you engage in, how it is very important in your career. So background story, I started in the unit as a trainee engineer from the pre-commissioning state of the refinery. And during the pre-commissioning state, there was still some kind of construction going on. So the line, check the valve, and check the valve location, check equipment location, check it on site, and do other things, as well as commissioning some equipment. And we're like, oh, this is not really a big deal. It was fun, and until we, transitioned into process, and the whole game changed. It was like a different thing entirely, because from what I thought was happening, or what I thought was going to happen, was quite different, because I was quite used to static systems, but now we are dealing with dynamic systems in such a way that you have to monitor the system because they are always changing with respect to time. So it's a dynamic system, and it was a little bit difficult to catch up, because you have to try to know what the bottom temperature is, try to keep the sensitive temperature of a plate at a particular temperature, or the column at a particular pressure as well. You need to understand the whole system to actually work effectively. I started as a field engineer before transitioning into panel operation. But on the field operation alone and the field process alone, the question is, do you understand what's happening? Because you really need to understand the full details of what's happening. Then, in quest of trying to get to understand what's really happening and increasing my career efficiently, I got introduced to RTsim by a friend. And guess what? He introduced RTsim to me at a championship or something to just flow along with. But it became a crucial part of my journey as a process engineer, because I could actually now relate with what I was doing in field with simulation. I could actually now relate with everything, both on field and on panel, and it gave me a better sense of what is actually going on. So if you see what's on the screen here, this is a compressed P&ID for the NHC unit. This is just showing you like a static parameter value, but on the field, these values are not static. They are always dynamic. They are changing with respect to time, with respect to flow, with respect to pressure and the likes. And if you check the RTsim, software, it gives you something similar. You now have the opportunity to relate to what is happening, not just statically, but dynamically. You get to realize that these things, what you have in the software is what is actually happening on the field and not just statically. Before getting into the field operations or the field process career line, I've always dealt with other software statically. I've always tried to see, okay, how can I get to understand what's actually going on here? For example, what we have here in this picture is an exchanger. I've always dealt with an exchanger as a static system, which is what everybody will want to see it as from other softwares. But in real life, it's actually dynamic because the temperature of the feed going in, it's not usually static. And then sometimes, depending on what we are trying to achieve, sometimes we are trying to reduce the temperature, increase the temperature and of a column or of a system. This exchanger becomes very important in what we are doing. And then you discover that, okay, this is not what we are really being taught in school, happening in real life. Though it gave us an idea, but it's a little bit different here. In real life, a lot of things are dynamic and you need to understand what is going on efficiently. So also, a lot of people don't know that when, especially as a field engineer or as a process engineer, a lot of designs and a lot of things you see, they are important and you need to question it. For example, if you are using the RTsim app and the RTsim software and you get to a place where it tells you open a valve, if you meet an inexperienced person, the person just opens it from 0 to 100. But in real life, it's not like that. And when you try to compare it with other softwares, you might think that it just opens from 0 to 100, but no, it doesn't work that way. If you check it very well, they will tell you open 20% before transitioning into other values. There is a reason why they said you should do that. And one of the reasons is because when you are dealing with a motor systems, there's what is called thermal shock. When you open a feed to an equipment with a particular temperature, especially if the equipment is at a lower temperature, once the feed is coming, there's a thermal shock happening in the equipment. And this is not what we want for our systems because it tends to reduce the lifespan of our equipment. Also, one thing we also look at is not just thermal shock, we also look at possible thermal expansion. And a lot of people don't know that sudden increase in temperature of a particular equipment tend to reduce the lifespan of the equipment. So I don't think there are other softwares that give you this idea. You really can't find this anywhere. And that's why when I got to interact with RTsim, I started more like a challenge, but it made me a better process engineer. It made me a better field engineer. I now understand what's happening. In engineering, there's what is called cause and effect. In cause and effect on a system, it means when something is happening, when you're doing something in a particular position, let's call it A, you might be seeing the effect in another location, B. So once there's an emergency or there's something to be done at position B, you have to understand that the cause or what you are doing there is likely going to cause another issue somewhere else. And the truth is, you really can't get to have this feel of how these things occur, except you really understand it efficiently. And frankly speaking, RTsim is one software that brings you very close and interact with what is actually happening in the real world scenario. So, like I said, the advantages of having this simulation environment is the fact that it represents the virtual representation of the industrial processes. It helps you in designing and optimizing operation, and especially in modern chemical engineering or process engineering. Also, there's something a lot of people do not know. In the real world, it's not the time to do trial and error. In the real world, it's not the time to check if something is working or not working. You need to understand, you need to move with a sense of accuracy, and you need to be quite decisive, because a lot of things can go down in less than a minute. Billions of dollars can go down in less than a minute. And these are things you really don't want to meddle with. So you need to have an accurate understanding of what is actually happening. You don't want to play with a system that, for example, I once had an experience on field where the reactor temperature was meant to operate at a maximum of 300 degrees centigrade while I was at the Penex unit. It was meant to operate at a maximum of 300 degrees centigrade. But something happened suddenly while we were trying to have an emergency shutdown. And during the emergency shutdown, there was a valve that was to be opened. We forgot to open that valve because it wasn't really a necessity according to the operator in panel. He just opened it for a while and then closed it back. Nonetheless, there are other reactions also going on in the reactor which could actually have effect on the temperature of the system that was not being taken note of. And then we had what was called thermal increase in the reactor. Some people might tell you is temperature escalation in the reactor. And at that point, the temperature moved above 400 degrees centigrade. And above 400 degrees centigrade, there's likelihood of the catalyst to be damaged. Now, as the temperature was increasing, though there were some little alarm trying to give, but the truth was only few people actually had an idea of how to work on the system efficiently, especially the Penex reactor. So what I'm trying to bring out is, on the field, it's not when to do trial and error. You already have your environment to carry out things, to make all the mistakes. If you check the RTsim software, when you skip a step by mistake, it tells you error. You know, okay, when I'm on the field, I don't do this, right? If you check the RTsim software, it will tell you, oh, try to line up the cooling water line before you try to do other things. There's a reason why it's telling you to line up the cooling water line first. You don't go to the field and try to meddle with these things, because you could cause damages that are over millions of dollars. So one is the cost, reduction in cost and risks. Two, it increases efficiency of your equipment. And three, it increases your safety. Your safety. In engineering, we personally have a rule which is called safety first. Safety first, safety always. You need to understand what you are doing in field. This is not the time to meddle with things. This is the time for professionalism at its peak. Also, it enhances your decision making. And a lot of people do not know. I don't know if I have much time, but a lot of people do not know that during one of my interviews, I was asked some simple questions like, what's an exchanger? And can you describe a system, or have you seen a valve before? Do you know how these things actually work? And guess what? I had very little knowledge about these things. And if I had gotten hold of softwares like RTsim, a lot of things would have been much more easier for me to deal with. And I feel people generally do not know how important this software is. A lot of people do not know. A lot of people do not actually know. I get to deal with software. For example, I touch an exchanger, for example, and it's showing me the picture. When I got to the field before, I don't even know how these things work, especially as a trainee engineer, and I don't even know how they look like. I had to start saying, okay, this is an exchanger. Okay, why is it fixed exchanger? Why is it floating head exchanger? Why do we have plate type of exchanger here? Every design, every process has a reason. That is what you must know. And from interacting with this software, it already starts keeping your mind in that inquisitive state. You start asking yourself, why is this here? Why is this done like this? Do you know that every line designed in the refinery has a reason? There's a reason why they are using 16 inches. There's a reason why they are using 32 inches. All these things has reasons. And you can't really question these things until you know about them, until you get to have an idea about them. And a lot of softwares won't introduce you to these things I'm telling you about. But when you go to the real field, when you go to reality, we are not dealing with static systems anymore. We are dealing with dynamic systems. So we need to understand what we are dealing with. Also, from the panel part, a lot of people do not know that in the refinery, especially if you are a bit unfortunate, you can work in a section, perhaps in the field, without having idea of what's actually going on in the panel. You might actually work for years without having an idea of what's going on in panel. But RTsim gives you an idea to operate this thing from the panel side without actually being there. You know how to, it reduces the time in which it might take you for onboarding in panel operation, because panel operation takes time as well. It takes time and experience as well. It helps you increase your efficiency. When they said there's a set point at a particular for a particular pressure reliever or for a particular equipment, you already know what they are talking about. So it's not really like a new thing for you. And people generally, I keep repeating it, do not know how powerful this software is. And fortunately, when I got the invitation, I was happy because I had the opportunity to get to know more about this software and to expand my knowledge as well, both in process and in field operation. So industrial application, basically, it helps in your training capacity. It provides real-time experiences. It bridges the gap between academic and industry. You might even go for an interview and people will start wondering, are you sure this guy or this lady has not actually worked in the field before? Because they will be surprised. How come you know much about this? And that's the power of RTsim, right? So it helps you reduce trial and error and increase safety. It increases your troubleshooting experiences. A lot of people, again, I don't know how much time I have. I don't know if I have much time, but a lot of people do not know that in the refinery, you need to be really smart, especially if you are an operator. You need to be really smart. You need to know where the cause of an issue is in less than a minute or in less than a second. You need to be that smart. So troubleshooting or trying to check where an issue is coming from, it's very important, because it's the refinery is like a chain-like connection. Whatsoever you are doing in your unit is being affected in other units. For example, if the CDU, which is the crude distillation unit, is not working or is going on shutdown, a lot of other units might go on shutdown because that is their major source of feed, except if they'll partially be getting feed from storage or from other subunits, and that might not last long. So whatever you are doing in your unit, it also has effect in other units as well. Similarly, if you are working in places like NHT or motor spirit block, which is where you get your naphtha in form of your isomerate, basically. When you are working in such unit, whatever issues you are having is going to affect other units as well. There are other units you are sending feed to. So you need to understand your troubleshooting efficiently to make sure that the process keeps going. So also, a lot of people do not know that this will help you increase your process design and optimization. Because you have already been used to this system, you get to understand, okay, you start asking yourself, what if I put a bypass here? Will this system not work more efficiently? Will it not be better? So you start asking yourself questions. So other applications might not really give you these things. That's just the basic truth. I wish, and I keep telling myself, I wish I had the opportunity to have that first-hand experience with RTsim. I think a lot of challenges I faced would have been reduced in a shorter time. So there are other benefits like understanding equipment sizing, increasing your technical competence, increasing your problem-solving skills, and bridging gaps like simulation, trying to understand how to merge simulation in refinery and energy operation, as well as modeling for other things. So lesson learned along the way, and which I would like to tell you, is that one, try to stay curious and try to stay committed to learning. Try to stay curious, try to stay committed in learning. In this field, it is a continuous learning. And guess what? If I told you that there are cases where I get to tell my supervisor, these things is better done this way. It's better done this way. It's better done this way. And you'll be like, oh, yes, I think you are right. Let's do it this way. And it works very fine, especially when you are dealing with systems that have back pressure, which is one of the most common cases in the refinery. There are a lot of systems that gives back pressure. Do you know how to deal with it? Do you know where the issue is coming from? A lot of people do not know how to handle these things. And I am telling you from experience, RTsim is the only software that I've seen that can connect you to real life challenges. It will develop your technical skill. It will make you embrace innovation and other things. So also, for you to go long, please seek collaboration. When I say seek collaboration, try to collaborate, try to have that friendliness with learning, basically. Try to see how much you can get from a particular opportunity. For me, I'm seeing RTsim right now as a company that is trying to give opportunity to upcoming engineers out there. Right now, I don't know how long this opportunity would last, but then I feel like a time will come when it will not be that easy to access this software again. That's my personal feeling. But what I'm saying here is that it is very important that you have an open mind to opportunities, to learning, to trying to see how to solve challenges and other things. This is very, very important. And build strong academic foundation. I'm not gonna lie, there are some pages I skipped from this presentation, and I'm telling you that some little things, such as some little things you do, like your chemical engineering reaction, heat and mass transfer, thermodynamics, some of these courses are very important, because in real life situation, you get to see gases that behave like liquid. You get to see liquid that behave like gases. You need to have a dynamic mind to learn these things. Learn simulation softwares like RTsim early. Learn it early. I can't overemphasize this. Gain experiences through internship, develop problem solving skills, network with professionals. And this networking with professionals is a part a lot of people underestimate. A lot of people do not know how much opportunities you have in networking with professionals, meeting professionals in different fields. It gives you that capacity. It gives you that ability to go into the future and understand things better. So I will also advise you to remain resilient and embrace adaptability. There are opportunities you can get a lot from RTsim, which is transitioning from student to industry. There are hands-on operational and technological skill you can get. There are process understanding and troubleshooting skill. You can take self-assessment of yourself. You can check yourself and be like, okay, am I actually doing this better? Why am I not getting 100%? Oh, I missed a step. Why did I miss this step? And then you try to self-assess yourself, and then you try to do it better. You try to do it better and try to master it, because in the real world, there are no time for trials and error. These things helps develop you. I repeat, it helps develop you. I wish I had people to expose me to some of these opportunities. It's not late, and that's why, and it's never late, and that's why I am still embracing it till today. So please get yourself acquainted with softwares, simulation environment. Take your journey and begin with active participation, and just know that opportunities can open in diverse ways. There are some things I actually didn't write here, and I'm going to tell you. Understanding process and operation, it's, for me, it comes with experience, right? If I had the opportunity to deal with systems with simulation environment like RTsim, probably I would be working for myself, because I'll know, okay, I'll know very well how to connect systems together and how to connect equipment together, form a system, and then they operate efficiently in such a way that when there's an issue, I know where it's coming from, and I can build little things up, such as trying to have an irrigation environment for perhaps a large farmland and other things. Basically, I can decide to design or make an automated system that tend to in form of an engineering that is dynamic. One will not have to be there for these things to work. And the thing is, in engineering, you need to open your mind. You need to open your mind to active learning, expose yourself efficiently, because trust me, the learning in engineering never stops. It never stops. And it gives you the opportunity to build things yourself. Think yourself. Sometimes I tell people that are not chemical engineers or process engineers, please have this knowledge. You are studying courses like agricultural engineering or perhaps instrumentation engineering. This is also very important. So I think there's some noise coming from my background. I don't know if you can hear it, but I'll be done with my presentation right here. Thank you.
Thank you so much, dear John. It was actually really inspiring. Even I took for myself some of the points and I just write them down to make sure that I will do them during my work already. But guys, if you have any questions right now, we will be happy to answer. Please write them in chat, or you can just switch on your microphone and ask some questions. And John, I think you should open the chat because there is a wonderful story from one of our participants, Irfan. Thank you so much for your review. I read it and I started to smile really. So, John, I also suggest you to read it. I'm sure it will make you smile as well. So, guys, if you have any questions right now, we will be happy to answer. Please write them in chat. And John, while our participants are writing their questions, I will ask you one question. What would you tell yourself at the beginning of your career if you could go back right now? So if you could if you right now could go back in times when you was a student, what would you tell to yourself? Which advice would you give?
Okay. Okay. I'll tell my younger self to network, connect, try to connect with professionals in the field. It helps reduce the journey. Trust me, little advice can cost you a lot of years, can cost you reduction in a lot of years. Try to network with professionals in the field. It's going to help a lot. Two, try to get acquainted with softwares, simulation environment. Try to get acquainted with simulation environment. It is very, very important. Thirdly, do not limit yourself. When I say do not limit yourself to a particular spectrum. Don't try to limit yourself to be dynamic. Especially in the engineering world, you need to have the dynamic mindset because it can take you places. You can find yourself in different rooms and you need to fit in, you need to present, you need to show up. And that is the power of engineering. It exposes you to multiple opportunities and that you need to deliver. All right. So don't try to cringe yourself. Also, I would like to also say this: in engineering, it's from the beginning might not be easy, but the further you go, it gets easier with time. Sometimes the pay from the beginning might not be easy, but then the higher you go, the more experience you get, it gets better with time. You know, from a lot of people, when they see the pay from the beginning, they'll be like, nah, but trust me, it gets better with time. Try to gain experience from each company you have opportunity to be with. Try to gain as much experience as you can because it's going to matter. It's going to matter. Trust me, it's going to matter. When you find yourself in a water treatment plant, don't say, oh, this is water treatment plant, this is not oil and gas. So there's no much to learn. But there is actually, because when you get into oil and gas, you might start seeing water treatment as a subunit as well. You understand? So in the refinery, we have effluent treatment plant that gets to treat our effluent. Also, when you go to the upstream, you get to see treatment of water. There's what is called retained water from your oil and gas. There's the water gotten. How can you treat it before disposing it into the environment? So try as much as possible to learn from every opportunity you find yourself. Don't try to be closed-minded. That's one thing I would like to emphasize on as well. I think that is the advice I'll give to my younger self.
Thank you so much. Thank you so much. I guess we all should remember this, and while we are young and Beautiful. We should do as much as we can for our future career. Thank you so much, John. I guess our participants
Thank you
in
so much.
this Saturday morning are still a little sleepy, so we will post a recording with our talk. And if something, I will directly share with you the questions which they will ask in our WhatsApp chat. Okay?
Sure. I'll be happy to contribute. Thank you
Sure.
so much. I
Thank
do
you so
appreciate
much.
it.
Thank you
Thank you.
so
Thank
much.
you.
Thank you so much. It was a pleasure for us. And I think right now, dear AIChE community, it's time to go to documentation. We will make a photo right now all together.
Okay, before that, thank you very much to our mentor for the insightful and engaging session. We truly appreciate the knowledge and experience that has been shared with us today. Before we close the session, we would like to encourage to all participants to take documentation of today's activity, and we kindly ask to all participants to turn on your camera. All right, get ready everyone. We will take the photo in 3, 2, 1. Okay, once again, in 3, 2, 1. Okay, we have now reached the end of day 2 as well as the end of RTsim Software Training Series 2026. And also we will send the QC form in the group chat in the WhatsApp, and don't forget to fill it. And thank you for your participation and enthusiasm throughout this training. We hope this program has provided valuable insight and useful knowledge for all participants. I'm Mima, as your Master of Ceremony, would like to apologize for any shortcomings during the session. Thank you for your time and participation. See you at our next event.
Thank you so much, dear participants. I will send all necessary information about the competition and championship in our WhatsApp chat. And good luck in the championship. Thank you so much. Bye bye.